Gaussian matrix board containing X and O capture all the regions that are 4 directionally surrounded by X. So the region is captured by flipping all zeros into X's, in that surrounded region. Okay. A region which is captured by flipping, what is this? Is captured by flipping all the zeros into X in that surrounded region. What do I have to print? Output is X, 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 O, X, X. Okay, this one is a region. So given capture all the regions that are 4 directionally surrounded by X's. Okay, if we see this regions O, 4 directionally surrounded by X, the region is captured by flipping. Okay, so if it is surrounded from all the 4 directions, so they will capture this region. So okay, this region becomes this one, surrounded region. Okay, so X is X. What do I have to find? Okay, we have to capture all the regions that are surrounded by X. Is it recursive? That means this one is surrounded, then if there was a O here and that was surrounded by X, what if, let's see, so X, 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 O, X, 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 X. Let's see what will happen. O, X, X. So here we have only one region. So this region is surrounded by all the X. If it is O, then this region, this region, this region, then no region is surrounded from all the 4 directions. Okay, that means if we run a DFS and try to cover this region, okay, so it will from here, so if it converts into X, 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 no, so this is how to region is captured by flipping all the zeros into X's in that surrounded region. Okay, so if they all become X, if it was 0, okay, so this 1 2 3 4 3 4 3 4 1 2 3 4 1 2 3 4 so 4 cross 4 X 0 0 X and X X 0 X X 0 X X not X X. So this is fine. Now x, what will happen to this? So this region is surrounded by x from all the cases. If we run a DFS, it will get covered. But what if there is an O here also? That means that one will not be covered. So it is 0. That means if I start a DFS from a O node and try to cover all the O nodes from here, then my DFS should end at that point where, so at every step I should always have 4. No, at every step I will always have 3 conditions, right? So either O or X or boundary. So if it is boundary, stop the DFS, because that O, if it is the O, then that means we can cover it. Okay, that means cover it. If it is X, then fine. So this O has all the neighbors except the parent. Also parent is required. I'm not coming from the parent. It means parent is O, it is not a parent, so the neighbor is not a parent, and it is a X. That means my DFS, so I will start only from that point which has all the which is surrounded by all the X's. That makes sense? Does that make sense? No. So what if there is O? So can I start my DFS from here? So at this O, can I start XX O O? So that means there is no boundary. There is no boundary X. Then only I can start. That means start the DFS from a non-boundary. No. From a 0 node, only if it is not at the boundary, only if it is not touching the boundary. Okay, only if it is not touching a boundary. Okay, first condition should be this, right? So start the DFS from 0 node only if it is not touching a boundary. That means it can be surrounded by 3 O's. Okay, so what if this is there? So can I start my DFS from here? Okay, if you start, then I will go to an O node here, and from here it has 2 neighbors which are X, but one neighbor is a boundary. That means it is not a valid DFS. That means it will not no, let's traverse over the boundary and try to, so if I'm at a boundary, suppose, and I run a DFS from here and traverse try to reach all possible X's, all possible O's which can be reached from the boundary O. Okay, think in the reverse order. So instead of going at the boundary in the recursive call, let's start from the boundary elements only. Okay, so if it is a boundary element, that means as many zeros it can cover let's cover it. That means they will not be part of, they cannot be captured. Okay, so it will traverse, mark it a different character y. That means they cannot be covered. So after this I will have all the y's which cannot be covered, all the remaining o's will be there, right, and remaining x. Now my claim is, after covering all the, after converting all the o's to y, after converting all the o to y, like only starting at all those o which are at the boundary. Okay, so that means these o's can never be converted. Fine. Okay, then in what will I have? I will have y, some y's, some o's still remaining, and some x's. Okay, so that means now those o's which are remaining here, that means they are completely surrounded by, they are completely surrounded by x, right? Otherwise, if they are not completely surrounded by x, they would have been covered in my DFS step only. They would have been converted to y only. Okay, I think I got that. Let's try to find a traverse over this one, then this one, this one, this one. Okay, in all these four, try to pick and cover it. Okay, what's the function? Solve vector of board. Okay, I think we need to convert that. Void solve. Okay, vector of characters. Okay, so let's traverse our first row. So for int j is equal to 0, j less than n, j plus plus. So in first row traverse, first int n is board dot size m cross n. Okay, at least one. Okay, so int m safe to write board of 0 dot size n cross n. First go through all the column in the first row and apply a DFS from that row number is 0, column number is 0, pass the visited, pass the board. Okay, so then no, so if it is not visited then only, so if it is, that's fine, it will return directly. If the 0, j is not visited, let's remove it, that will not make any difference. Okay, so if it is not visited, first row I can convert it into 2 for loops or 1 for loop only. So j is equal to first column, first row, j is equal to last row, that means n minus 1. Okay, it's fine to have my DFS from here only, it will not make any difference. N minus 1, then write from I, first I less than n, I plus plus, so DFS on. So every row first column and go from n minus 1 at no every row in the last column, n minus 1 column, visited and board. So we will have DFS after this. So that means it will mark every after this. So 0j 0j n minus 1j I0 I n minus 1. So this one. After this, what will happen? So all my which are reachable, everything is converted to y, and everything which is remaining will be either 0 or x. So that means if it is not y, let's convert it into x. So for int I is less than 0, I less than n, I plus plus. So first iterate over the rows, iterate over the columns, iterate over the columns, j less than m, j plus plus. So if my board, if my board of ij is not equal to what is not is equal to x, that means if my board is not equal to y, is it not equal to, okay, so convert everything into x is not equal to y. So if it is not y, then convert either it is x or 0, convert it into x and return the board. Finally return the board. Okay, let's write the DFS function. So void DFS from int ij and what vector of boolean, what I'm passing visited, right? So at the visited pass and vector of the board array. Mark it as visited of ij is equal to true, mark it as visited, and traverse over all the surroundings of this is equal to 0, k less than, okay, in 4 directions I need to traverse. Let's traverse, and then I'm at ij, so where I'm going at I plus dx of j, and y is j plus dy of j. So I'm going at this. So if can I go there? So if x is, so if it holds these conditions, x less than n and y greater than or equal to 0 and y less than m and visited and this is not visited, so visited is false, then only do I, it is not visited, it should be equal to O, right? So from O only I will go to O. So let's start our DFS also from there only. So if my board of row is this, column is this, is equal to O, then only do the DFS. Similarly for the last column also I need to do this. Okay, so for this one also So board of 0 j. So if it is an O, then only start from the boundary. So then start from the boundary, and from that O visit all the O's. I think visited is not required, right? Because O is converted to Y. So visited is not required. Let's remove this. Visited is not required. So board at this becomes Y. Right. It becomes Y, and go to all directions. If it is O, then only go to XY, and then only go to that. I think N and M are required, so we can paste it here or define it as global. So size, okay, and M, make it as Y and go to all the 4 directions. Let's define dx dy to dx of 4 is equal to 0 0 1 minus 1 into dy of 4. Okay, what DFS I say tractor, you have the board. So board size, board 0 size. If board is, make board as Y. Okay, convert it as Y, let 0 as Y, and go to 4 directions. I say okay, dx of k, it is k, and if it is inside x less than y getting equal to 0, y less than m, and it is not this, it is board, it is O, then convert it into, then mark, go here, it will get converted to Y. So x, y and board. Okay, DFS is fine. Let's go to our solve function, and m, go to first row 0, every column. If it is 0, if it is O, then start DFS from 0j. Visited is not required. Visited is not required, pass the board. Visited is not required, pass the board. Board 0j. 0j. Is it 0j or n minus 1j? N minus 1j. The last row. Similarly, first column. So I less than n, first column. That means I and 0. So if it is 0, then I0, then it is last column, that means m minus 1. So start it here. Okay, so it will mark everything as y, all those which can be converted, which can be captured, they will be marked as, which can never be covered, they will be marked as y, and all those O's which can be captured will remain as O. So in this step, I think let's convert. So all these Y's, so if it is not Y, that means they can never be converted, then mark it as X. Okay, return the board. I think this should work, right? Let's see. Oh yeah. Y, and this is O. This is O. This is O. This is an O. This is an O. So go to everything. So if it is this, then fine. If it is this, then fine. for this. So is this, then convert it into otherwise this, return the board. Now let's write the remaining one. So dx dy is fine. I need a formatter. 0 0 1 minus 1 minus 1 1 0 0 and solve, write our DFS, so which I think is working fine. Okay, so where DFS n m board x y, if this works then okay. Okay, return is not required. Let me avoid it work x and y. Okay, wrong answer. What's wrong here? So everything in last row. Acha, we have to convert that y into o again. So after this, so if this is a y, convert it as to o, right? Because y, if this is a y, convert it to o finally. Let's see if it works. Yeah, worked. First go. Great. Let's go to next question.